Have you ever looked up at the night sky at all those countless stars and wondered, are we alone? It's a question that has captivated humanity for centuries. Our galaxy, the Milky Way, contains hundreds of billions of stars. And beyond that, there are hundreds of billions of other galaxies. Statistically, it seems almost impossible that Earth is the only planet to have spawned life, let alone intelligent life. This very idea is the basis for one of the most profound and unsettling questions in science, the Fermi Paradox. The story begins back in 1950. The brilliant physicist Enrico Fermi was having lunch with his colleagues at the Los Alamos National Laboratory. They were discussing recent UFO sightings and the possibility of extraterrestrial life. Amid the chatter, Fermi suddenly asked a simple but powerful question. Where is everybody? Think about it. Given the age of the universe, about 13.8 billion years, and the sheer number of stars, there should have been plenty of time for other civilizations to arise. Some of them would likely be millions or even billions of years older than our own. An older civilization would have had ample time to develop technologies far beyond our wildest dreams, including interstellar travel. Even with technology we can currently imagine, like self-replicating probes, a civilization could colonize the entire Milky Way galaxy in a relatively short cosmic time frame, maybe 5 to 50 million years. That might sound like a long time to us, but on a galactic scale, it's just the blink of an eye. So these civilizations exist, they should be here. We should see evidence of them everywhere. Probes, megastructures, radio signals, something. Yet we see nothing. The universe is eerily quiet. This is the heart of the Fermi Paradox, the stark contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. So where could everyone be? Scientists and thinkers have proposed many fascinating and sometimes terrifying solutions to this cosmic silence. These solutions are often grouped into a few main categories. The first category suggests that intelligent life is simply much rarer than we think. This is the rare Earth hypothesis. It argues that the conditions needed for complex life to evolve are incredibly specific and uncommon. You don't just need a planet in the habitable zone where liquid water can exist. You also need a stable star, a large moon to stabilize the planet's axis, a magnetic field to shield from solar radiation, plate tectonics to regulate the climate and recycle elements. The list goes on and on. Perhaps the combination of all these factors is so unlikely that Earth is, for all practical purposes, unique. We might be the first, or even the only intelligent life in our galaxy. It's a lonely thought, but a possible one. Then there's the second category of solutions, which are a bit more dramatic. This is the idea of the Great Filter. The Great Filter is a hypothetical barrier or challenge that is so difficult to overcome that it prevents most life from reaching an advanced spacefaring stage. The scary part is, we don't know where this filter lies. Is it behind us, or is it still ahead of us? If the filter is behind us, we might be one of the very few, or the only ones, to have passed it. Maybe the leap from non-living chemicals to simple life is the filter. Or perhaps the jump from single-celled organisms to complex, multicellular life is the impossibly hard step. If so, we're the lucky ones. We won the cosmic lottery. But what if the Great Filter is ahead of us? This is a much more sobering possibility. It could be a technological challenge we haven't faced yet, like the development of artificial superintelligence that inevitably turns on its creators. Or maybe it's a societal one, suggesting that any civilization advanced enough for interstellar travel will inevitably destroy itself through war, resource depletion, or ecological collapse. In this scenario, the silence of the universe is a warning. Other civilizations reached our stage of development and then they failed. They didn't make it. This implies that we are racing toward our own potential doom and the clock is ticking. There's also a third category of explanations, which proposes that extraterrestrial civilizations do exist, but we just can't see or hear them. For instance, maybe they're communicating in ways we can't possibly comprehend. We're looking for radio signals, but what if they use quantum entanglement or gravitational waves for communication? It would be like us trying to find internet signals with a smoke signal detector. We're just not on the right frequency, technologically speaking. Another idea in this category is the zoo hypothesis. This theory suggests that advanced civilizations are out there, and they know we're here. But they're deliberately avoiding contact, treating Earth like a nature preserve or a zoo. They're observing us from a distance, allowing us to develop naturally without interference. Maybe they have a prime directive of non-intervention, just like in Star Trek, We are an exhibit, a protected species in a cosmic wilderness. Or perhaps they're simply not interested. Consider our own perspective. Do we try to communicate with every ant colony we come across? To a civilization millions of years ahead of us, we might be as insignificant as ants. Our thoughts, our culture, our entire existence might be too primitive to even register as interesting. They might have passed through our solar system ages ago and found nothing worth stopping for. There's also the possibility that advanced life takes a form we wouldn't even recognize. We are carbon-based life forms, looking for similar life. But what if life can be silicon-based, or exist as pure energy, or live in the plasma of a star, or the depths of a gas giant? We are searching for a reflection of ourselves, but the universe might be filled with beings so alien that we wouldn't even know we were looking at them. So, what does this all mean for us? The Fermi Paradox isn't just an abstract thought experiment. It forces us to confront our place in the universe. On one hand, the possibility that we are alone is both humbling and empowering. It means that all the art, science, music, and love of the known universe exists right here on this little blue dot. It places an immense responsibility on our shoulders to protect this fragile spark of consciousness. If we're it, then we are the universe's way of knowing itself. On the other hand, the possibility that we are not alone, but simply unheard, fills us with a sense of wonder and anticipation. The search for extraterrestrial intelligence, programs like SETI, continue to scan the skies, hoping to one day catch that faint signal that proves we're not the only ones asking these questions. That single detection would fundamentally change everything we know about ourselves and our place in the cosmos. The silence of the universe is profound. It could be a sign that we are precious and unique, or it could be an ominous silence that precedes a test we have yet to face. Or maybe, just maybe, it's the quiet before the conversation begins. We don't have the answers yet, but the question itself, where is everybody, continues to drive our curiosity and our exploration of the final frontier. As we continue to gaze at the stars, we're not just looking out, we're also looking in, trying to understand what it means to be human in this vast, silent universe. Thanks for watching. If you enjoyed this journey into the cosmic unknown, don't forget to like, subscribe, and hit that notification bell for more deep dives into the mysteries of science. What do you think is the solution to the Fermi Paradox? Let me know in the comments below. See you next time.